Hello, everyone. My name is Ricardo Gonzalez, and for anyone who doesn't know me, I'm a second year PhD student in Cornell Tech, working with my advisor and co founder of the XR Access organization, Shiri Asenkot. My research focuses on how can we make use of AI and design it to create accessible experiences for people with visual impairments. But enough about me. In this panel, we will be discussing how can accessibility insights and prototypes created by researchers get implemented in XR technology products. Accompanying me today, we have three fantastic speakers. I'm really happy with the people that we got here today. They are experts in VR and AR technologies, each one of them with experiences working with different communities with disabilities, and they will be sharing with us a bit of their research work and their experiences and how can we translate this research work into practice. With that now clear in mind, I will allow the speakers to present themselves, and I would like to, Stephen, start with your presentation.
Thank you very much, Ricardo. My name is Steve Feiner. I'm a professor of computer science at Columbia. I've been doing research in XR since the late 1980s, emphasizing mostly user interfaces and software for people who are working both alone and together, indoors and outdoors. And for the past several decades, we've concentrated mostly on augmented reality. In terms of accessibility, I worked on one project with Yuhan Chao, who is Shiri Asenkot's PhD student, and Shiri, which involved the design of AR systems to help people with low vision navigate stairs. And we were looking at combinations of audio combined with projected imagery and also the use of AR eyewear. I have an ongoing project with Maggie O'Neill, with students Max Bennett and Navi Chedda, in which we're currently developing VR games for kids who have cerebral palsy for use in rehabilitation. And we're actually currently running a user study in that project. And I think quite exciting is we are about to enter the second year of an NSF REU, that stands for Research Experience for Undergraduates. And it is a summer program being held jointly between Cornell Tech with Shiri Asenkot and Columbia with Brian Smith and me. The topic is on building accessible XR, and we have 8 undergraduates who are going to be joining us the first week of June.
Okay, thank you so much for that introduction, Stephen. Now, Raja, could you introduce yourself?
Okay, yes. Hello, everybody. This is Raja Kushalnagar. And that's how you spell my name. Really, since I don't use my auditory name, I just know the spelling of how it is produced in English, and this is how you write it. Okay, so for example, going from auditory to visual information, when you're signing a language, it's different. At the same time, and in person, when you're informing them of technology at an undergrad level, when I did my work at graduate university and graduate level, I had my access where I was physically very involved with technology. And since I'm working with hard of hearing and deafblind people, I did my research at that at Gallaudet University in the fall semester. At the same time, there was a lot of research dedicated to the technology side of it. So we had to go through a lot of policies, like research with XR technology specifically, as well as information technology.
Okay, thank you so much for that introduction, Raja. So now, Haley, could you introduce yourself?
Yeah, thanks for the introduction, Ricardo. My name is Haley Adams, and I am wrapping up a PhD in computer science at Vanderbilt University. In regards to accessibility research, I'm interested in creating development tools and design guidelines for improving accessibility for people with low vision, which is a vision impairment that can't be corrected through glasses alone. And for this work, I quantify how different visualization techniques affect people's behavior and make them better or not better at performing tasks. I am also developing a low vision simulator to allow designers without vision impairments to get an idea of how people with low vision are affected by design decisions in XR applications or even physical products.
Okay, thank you so much for that introduction, Haley. And as you can all see, we have varying degrees of experiences and different work in different fields. Steven has some experience with motor impairments, visual impairments. Raja has experience with deaf and hard of hearing. And Haley has some experience with people with visual impairments. So now for the first question, and I want to get right into it. I would like to ask all of you to talk a little bit about, well, some of you already mentioned that you have been working in XR accessibility, like Haley with the vision simulator. But I would like to know a little bit more about what are some of the key findings of this work, and maybe, yeah, just talk a little bit more about that.
So for this question, we'll address that component of my research. So disability simulations, like my own for low vision, can be powerful tools for educating designers about accessibility needs, and by letting them experience having a disability firsthand. But they're not without limitations. And it's important to understand these limitations if we want to use disability simulation to truly improve accessibility. For example, people with disabilities typically perform tasks just as well as people without disabilities. And that's because people are smart. They develop compensation strategies over time so they can keep performing daily tasks. But for some tasks, it may take them more time, and certain tasks like crossing a street may expose them to more danger. In contrast, when someone uses a simulation, they're very suddenly experiencing that disability, and they can behave differently because of this, because they haven't had time to develop compensation strategies. The actual experience of the disability is also different when it's simulated. So what you find in research is sometimes people with simulated vision loss, for example, will actually perform worse on tasks than people with real vision loss. Which is to say, disability simulations are great. They can allow for more rapid and iterative assessment of accessibility during the design process, which is especially nice for groups without ready access to user testers with disabilities. But research has shown that they cannot and should not completely replace people with real disabilities because there are fundamental differences between how real and simulated users interact with the world around them. So my big key finding, I suppose, would be to really improve accessibility, especially if you want to use a disability simulation. I think most people would agree that they're best used in conjunction with feedback from real test users.
Yeah, so what you're saying is very, very interesting because, yeah, the simulation can help people without the impairment get some idea, but fundamentally, and I'm pretty sure that other people will agree with me on this, is that when you live with that impairment, especially since birth, your way of perceiving the world will be completely different. And so certain concepts won't make sense in the same way that it makes sense to people with the impairment. Maybe, Raja, you can enlighten us a little bit more in this topic.
Yes, I did grow up with some hearing. But I do identify myself as deaf. There is a difference between deaf and hard of hearing. There are some people with complete hearing loss and no auditory stimulation whatsoever. And they have never ever heard any environmental sounds or any auditory stimulation. So We have to clarify and explain what other situations are like to them, whereas a hearing person would just naturally experience them through their auditory senses. The same with vision. In an environment where they're seeing their objects in environment clarity, whereas a person without any vision, they're losing that information. So context is important. Concept and experience is important. And for me, growing up as a hard of hearing child, I was trying to lip read, but again, it's really hard to understand a concept and even catch 100% of a sentence, because I did not have like 100% auditory stimulation or information going to give me some sort of grounds to process the information that I'm receiving. So I have hearing loss in both ears. So I am using my vision as a backup support. So that's how I'm receiving my information. So I'm mainly relying on my vision and what I'm seeing in my environment to understand the concepts and all the situations that's happening.
I think that's a fantastic observation. Like, this just describes the nuance of how people with different disabilities, and like Haley mentioned, they find a strategy to overcome that lack of channel of information, let's call it that way. And I think that's just amazing. So I want to dig more into the topic at hand, and maybe Stephen can start with this question. I wanted to ask to you, have you had any experience collaborating directly with industries or companies that develop VR and AR systems? And if so, what has been your experience, or if they're having any barriers to this if you haven't?
Thank you, Ricardo. So the experience I've had working with companies has not actually addressed accessible XR. So I can't really speak to that. One thing I can talk about a bit is some of the lessons that we've learned from some of the work that we've done. And one thing that really struck me was in the work that Yuhan Zhao did. As I mentioned, part of what we tried to do was to build for AR eyewear. We were using HoloLens 1 in that project. Ways of being able to provide augmentations to what a person saw that would help a person who had low vision navigate stairs, descending stairs, and going upstairs. And one of the fascinating things is that we all complain about the field of view of AR eyewear right now. It's way too small. What people mostly think about when they think of the field of view things, they think about width. And if you're in industry, you also talk about diagonal because that will be the biggest number, and people in industry really like to use large numbers. But we talk about things like wide field of view and wide stream movies. We don't really talk a lot about depth. And for someone going up and down stairs, it's nice to know what's happening to your left and to your right, but what's most important is happening down. Normal field of view, if you're looking straight ahead, not angling your head down in the slightest, you get to see down around 70 degrees. Now, the entire field of view vertically of a HoloLens 1 is under 20 degrees. HoloLens 2, just under 30 degrees. Pretty much every optical see-through and even video see-through headset is way below what people naturally see. And for walking down the street, if you simply hold your head straight as you have normal vision, and you just look straight ahead, not angling your head down, and let's say you experiment by putting something very bright and shiny, like let's say a little piece of paper on the ground, put your toes up right against it, back up a little bit, and you won't get very far back before you'll be aware of that on the ground. You obviously wouldn't be able to read it, but you can know that it's there. So as you're walking along the street, if a dog runs in front of you, if there is something that you might trip over, you're going to be aware of it. Now, if you want to add virtual stuff, you're a person who does not have who has a visual impairment, we'd like to be able to to highlight things that are within your field of view. And with something like HoloLens or any of the existing optical see-through commercially available systems, their field of view is much, much smaller vertically than horizontally. And so in the things that we did, we, for example, did visualizations in which we were only able to visualize directly on top of things like stairs significantly ahead of you, not the ones you were about to put your feet on or the ones you're about to put your feet on after that. So we had to do things like producing visualizations that were raised up in the field of view, directing your attention downwards, but stopping right at the point at which the display's ability to augment stopped. So that notion of hoping to get the folks who make these systems sensitive to the importance of being able to augment more vertically than current designs can do, I think is going to be really important.
I see. And so you would say that right now, what defines some of the times the research that we can do, it is defined by the specs of the product. In this case, like you said, the HoloLens has just a limited field of view vertically.
So in terms of hardware, people who are not doing hardware research are going to be limited by what's there. If you're doing software, you're generally developing the software. You might be limited by some of the lower level systems that you're using. But as researchers, we try our hardest to go beyond what's out there. But in what I do in my lab right now, we are using commercially available products or things that might be not quite yet commercially available. We did some work using Snap's new version of spectacles, which have a relatively small field of view. They're not yet a product, but they're very compelling in being essentially standalone and looking, if not exactly like regular glasses, successively closer and closer to things that people would be comfortable being seen wearing. Back in the fall, Snap very generously donated to students in a course that I was teaching, Snap Spectacles, which are a new, not yet a product, augmented reality, standalone augmented reality eyewear. And the students use those to create a variety of interesting projects. And that kind of thing, I think, is really beneficial both to the students who get to work with state-of-the-art hardware, and also to the company that gets the feedback of having a bunch of really bright kids, beating on their software and hardware.
Okay, I see. Maybe now we can turn into the discussion into, and I would like maybe Haley and Raja to pitch in on this one, into how can researchers improve the communication of their knowledge and the research artifacts that they make, so that industry, and I also believe that we should add into this education, how can industry and education make use of these research artifacts? Because definitely what people learn and see in their learning environments will greatly affect what gets implemented when we go into the real world. So maybe Haley can start and Raja can follow up this one.
I think actually one thing that's interesting, at least I've noticed with a lot of people graduating with PhDs, so we'll actually go into industry, and we're seeing a lot of this. And I think that actually helps. At least I look at things through the lens of computer science because that's my field. But a lot of them are going into these bigger tech companies that are designing technologies that will ultimately be used. And they maintain connections with academics as well, which is hopefully going to help. As far as a more broader communication goes, social media is actually quite good for that. I've personally learned a lot from others, and I've hopefully taught others on Twitter. But even just looking at different communities, because one problem is often that the actual people who need and benefit from accessible design are not getting to get their input in. So even just going to Facebook groups to make those connections and improve baseline understanding I've found really helpful and is becoming more common. What do you think, Raja?
I agree with Haley that the more and more there are more and more benefits in connecting with people in different ways that we go in the industry. And also, I know that I moved to design and, users with disabilities, so that imagine that, we're building all sorts of things for all people, access and users, especially with people who have technology limitations. So I'm noticing that more and more of the time, that connection, internet connection with research on technology and how we pull in that research and we make it much easier for people.
Yeah, I totally agree with what Raja and Haley said. I believe that especially social media platforms and communication channels have to make a lot of effort into making their platforms accessible, because this is now the main way that people with different impairments can actually advocate, because these are the places where the conversation happens and where people communicate with each other. And certainly there are still many limitations in some of these applications. I won't say any names, but they know who they are. And we really need a lot of work to be done on that side of things.
Can I add something else, Ricardo?
Of course, Stephen.
Okay. In terms of trying to improve the way in which we communicate stuff to people in industry, we are now finally at the point at which there's a lot of rather affordable VR hardware. If you consider smartphones for non-head-worn AR, there is, with literally getting better with every passing week, support for doing AR on smartphones. And what I think that means is that if there is some knowledge that's embodied in an application, being able to make that application available for people to try, is incredibly powerful. For a long time, we've had open source. My lab has put out a variety of things open source, but open source means that someone who needs to even know what open source means needs to be a programmer, needs to go and, download a built version of it or actually contribute and try something out. And I think now we're talking about the ability for someone to simply share an application that might embody some new way of doing something. And that new way of doing something could be a way that could be adopted by industry. And more powerful than simply reading about it in the paper, the idea would be that you could actually try it yourself.
Absolutely. I think Stephen went to the heart of the issue, and that is that the researchers that put out their work and also open them up for people to try them out is also the research that is getting the most attention. And yeah, definitely, just trying it out, it makes the whole experience more vivid and you understand what is going on. I would like to wrap up the panel by asking you one last question. This can be taken by anyone. What do you think can be done to improve and foster the closer collaboration between academia and in industry to turn research into practice?
People, particularly researchers, love talking about their work by and large. And I've heard from multiple people and through my own experiences, if you see someone working on, for example, an accessible project or design or research in industry, and you reach out to them, to ask them a question about this work or ask advice on something, they're more than likely going to oblige. Also, I've noticed some companies will also come to academic conferences and present work, which I think does a lot for lowering barriers between communication between academia and industry.
So following up on what Haley said, I think there are definitely open communications channels between people in industry and people in academia. There are many papers at the major research conferences on AR and VR that are authored by people in industry. And usually people in industry were at some point in time, people in academia minimally getting their PhD or another advanced degree in many cases. So I think a lot of that is working, and I certainly can think of colleagues at Facebook, now Meta, who've generously donated headsets that we're currently using in a class that just wrapped up. So, providing tools for use by people in academia, for use by students who are learning, and making it possible for people to do more good stuff, I think just helps everyone.
Yeah, absolutely. I think that just sending those resources gives so much more opportunity for ideas to come to fruition. I wanted to hear Raja's thoughts about this because I really love his work on closed captions and augmented them for classroom environments. I don't know if you have any comments there to include, Raja.
Yes, so now, because I've been doing closed captioning research, and I've been doing that with limited technical abilities, and I've been able to show the limitations. And so we're able to do that. We have challenges. We have all sorts of different work that we're doing with so many deaf people and with hearing people. And so what we're doing is we're connecting and doing as much as we can to make that work, to continue that research. With XR, with that symposium, those meetings. That's what we're doing.
Okay, I think we are done here for today. I would like to thank everyone for coming here. Haley, Steven, Raja, three amazing speakers. I'm so happy that I had you three here. And I guess we can continue for the Q&A session. And I'll see everyone soon.